So as we get rolling today, oh gee, it would help if I unfroze that. So this is the review that is going to be the closest to the final in length and type and how we kind of mix everything together. But I'm also going to try and blend in as we kind of bounce around a little. Some more things I might put on my note sheet or something like that. I have posted at this point, I posted my completed note sheet. The one that I did for every single section. It's on Classroom now. It's on the main page. So if you want to get caught up on some or see what I've suggested on things, you can do that as well. So, okay. I'm taking a look at this first page mainly to see, is there stuff that we haven't talked about yet? And I'm like, okay, let's see. We've done some inequality work. We've done some equation work. Now, I notice maybe one thing I'd consider, I'm like, I see a bigger fraction there than this one. You're like, but I'm out of room on equations. It's true, but I've still got room for other examples on the back. But let's kind of look through this again. Fraction, combining like terms, ooh. Okay, here's one thing we haven't talked deeply about, at least as far as the notes go and the review goes. What happens when I have a mega fraction problem? When we do, this is the one where I find the denominators that are different. I don't need to do 2, it's there twice. I don't need to do 5 twice. Just the ones that are there a single time. We're going to multiply those together. So 5 times 2 is 10. That's where that's coming from. And we're going to distribute that all the way through. So when you're distributing it, you've got a couple of options. You can multiply by the top and then divide by the bottom. So you could do like 10 times 7 and then divide that by 5. That would work. Or you can just do the whole fraction at once, but you've got to remember to put it in parentheses. So I do 7 divided by 5. I get the same thing. So either one is going to work as I distribute through here. And I'm just kind of keep going back and forth so you can see both. But if there's things with x's, don't lose your x's. That's not going to help me, though. So just like that, all of my fractions are gone. And so once I get here, now my goal becomes like we did when we had variables on both sides. Okay, sort of like this one. I need to get all my variables to one side. Now, it doesn't matter which side we do it. Personally, to me, I like to avoid negatives. So I'm going to move the 14 by doing the opposite. If you did minus 15 because you like x on the left, there's nothing wrong with that. One x and x are the same thing, and I mention that because in this case, getting that situated is going to be an advantage to me because I'm going to have one less step that I have to do. Might I suggest, I'm going to star this one, might I suggest putting that one in the other examples on your note sheet? If you're not going to remember that you multiply those together, I'd consider it. That's one I think would have preference to do something like that. So maybe. Another one I want to take a peek at, because it's a little bit different, is going to be number 7. Because you're like, okay, well, what's bad about 7? It looks like it's just some distributing. That's not too terribly bad. Oh, but there's a fraction over here. So, as we've seen in other circumstances, if I put the 1/2, again, the divide is just my fraction button. I don't have a fancy fraction button on these. So I get to here, and you're like, okay, so what was so bad about that? All we got to do now is get all our x's to one side, and we're going. Well, that's the dilemma we're about to run into. All of our x's went away. So I'm going to give this one a little bit of a star, too. I might just want to kind of make a passing mention, though. If you get here, it's not no solution. Since the two sides are equal, okay, every number that works for x is going to go in here. Now, if I would have gotten rid of all the variables, and at that point, these two numbers on both sides of equals wouldn't have been the same. Let's say it would have been like 12 equals 6 or something like that. Then it's no solution. But if the numbers are the same, it's like all the solutions. It's the exact opposite of that. So something to be aware of when we're looking through those. So I keep looking, and I'm like, okay, oh, we did inequalities. Ooh. Absolute value. We haven't played with this yet. So, okay. So, absolute value. I'm actually going to copy this one onto my note sheet to do it, because I want to do this anyway. Probably should divide this off a little bit. Okay. So while we're here on the topic of absolute value, let me make note of something here that we may want to jot down. We are always going to have two equations when we do absolute value. Guaranteed. There is no exception to that. So the other thing we need to make note of is we need the absolute value alone before you split it into two equations. So what do I mean? So if this was just the absolute value on the left equals some number, I'd be ready to break it in two already. But this one, there's a number going on outside. There's an operation going on, which I need to do the opposite of to get this alone. So here, I would need to divide by 3 first. And once I get here, yeah. Okay.
It's 0x.
Okay, so once the x's all go away, if the two sides aren't equal, then it's no solution, yeah. Okay, here we're ready to split. So I'm going to have two equations that this turns into. The first one, I just literally rewrite the equation, but I lose the absolute value bars. For the second one, I'm going to change the sign of the answer. So since it was positive 6, I'm going to make it negative 6. And I'm going to solve those two mini equations, and that's going to be what I've got. So here, if I plus 4 to each side, this is getting a little more snug than I would like, but that's okay. And the nice thing about absolute value is whatever you do to your first equation is exactly what you're going to do to your second one. Nothing different. So we got a little bit of a bonus there, that not only did we get to add a little bit to our notes, but we also got to deal with one of the problems at the same time. And we might see another one of those here in a bit that we decide we're going to do. So I'm like, okay. So let's see. As we flip to the back, let's see if anything new is coming. Here come the angles. So I've got my supplementary. I got an example. I got that here. So I'm good on that one. Ooh. Now we have a triangle. Now, I don't think I need an entire example for a triangle, but I will say this. I would make sure I wrote triangles are 180 degrees. I might even make a little note here to make an arrow over there and say, hey, the angles in a triangle add up to 180 degrees. So, I mean, we can still do this one, because all we're going to do for our equation, and it even says the angles add up to 180. So since I'm adding, I'm going to combine my stuff that's alike right away. So I got 1x and 2x and 3x is 6x. And if I combine my plain old numbers, 3 and 7 is 10. Watch your signs. Minus 4 is 6. And now it's just an equation to solve. And we keep doing opposites. And we've written this in several places on our note sheet as well. So we get that 6 out of the way first. And I'm just going to find what I'm being asked for. All I'm being asked for here is x. They're not asking me to find every angle. Or even one angle. Just find x. You're done. Okay. And I can do that. But I keep looking at the rest. I'm like, I've already got a problem for vertical angles. I don't need to do that one. I look at my inequalities. I've done some stuff with graphing on those. So maybe I need to do that. Maybe I don't. Now, this is me. I'm probably going to look at that, and I notice on the back there's a part strictly for graphing inequalities. And so I've written the and and or thing, but I really don't have anything up here yet. It does. So when I get back here, maybe I decide, and it might be a good idea, because as just was mentioned, there was a special case going on here in number 15. Let me make my box in here a little more centered up here again. I'm going to keep stealing straight from this. So I look and I go, okay, it doesn't look complex mathematically, and it's not, until we get to this last step. Because, as Aiden mentioned, if you divide both sides by a negative, only if it's a negative, you don't flip every time, we're going to flip the inequality arrow back the other way. So notice it went from going right to going left.
But what if when the equation starts, the number to the right side?
It's this is the only time there's flippage going on. It's not just for any time I see a negative. It's my own word. I should copyright it. Flippage. And so then I've got hints again down here at the bottom to help me with the graphing portion. underlined or equal to, we'll fill it in. Arrow going left, so are we. So I've got me an example into my graphing inequalities. We're making some progress here. And since I see an and statement coming, which is another one of my unusual ones, I'm going to go ahead and I'm going to jot this one in there too. So here, nothing fancy. They're already split into two. Don't have to play that game. I'm going to write a little small because I want to be able to get my graph in here. Just keep doing opposites.
You can pick any two.
Opposite of adding 7 is to subtract it. So I'm going to add one extra thing in here just to kind of assist a little bit. So when you're dealing with and, this is going to be the same as if you had, I'm just looking for a minute here. Just so some of you remember at the end here, an and statement can be the three-parter. We have one of these on the front. But just so you know when you're thinking about the graph, ooh, the three-parter and the and one, the one that has two separate parts, are going to look exactly the same on a graph. Just moving this up a little so we can see it. And that and is going to be where the two endpoints go, and we just go in between. So at -3, we're an open circle, because it's just greater than. At 4, we're a closed circle, because it's or equal to. And we just color in the middle, because that's what ands look like. So we're going to have lots of good clues here to help us and plenty of time to work. The question is going to be, have we done our due diligence with our practice? That's going to be the thing. Looking to see if there is an or. Just a second. I'm trying to remember. No, there's not another one, so we're going to do that one. Okay. One more one to put in the inequalities section. Since I don't see another or coming. Oops. It'd help if I was on the screen, though. So if I have something as straightforward as, because I want to see what all these things are supposed to look like. If I get the or statement, or statements go out from each other. X is less than, we go to the left. X is greater than, arrows eating X. We go to the right. So now I've got pictures of and or graphs. So just by doing the ones in there, we've knocked a lot of that out, I'm just trying to look ahead here again. Oh yeah, we've done a lot of this, but let's see what we got. So let's see, what do we got left in the chart here? We got slope, some generic graphing, and anything else. Okay, so slope. This is where it gets interesting. Because with slope, when I come to this part, I get here, and there's lots of things to remember with slope. So I'm going to be using up a lot of my above space, trying to remind myself of some stuff. So let's see. Slope as a formula. So I've got my formula. That kind of helps me with this top part. So maybe just a straight slope problem would not be a bad idea here. With the reminder, even though it's not done in this problem, and then we just follow y2 minus y1 x2. Oh, of course I get a special case. Minus x1. Okay. What happens when you divide by 0?
Undefined.
It's undefined. It's an error. That's the only time that we don't just keep the number. Every other time we simplify it, we get a number. That's it. But this is going to help me that way, and it's going to help me in remembering what the formula is and how it works. So even like if you were doing number 19, you don't have to use all those numbers. You can pick any two pairs of numbers in there. Like you could even do and then just use those 2 points in the formula. It's exactly like number 20 is, and 21, and 22. So that part of the slope, I think we got pretty good. If the arrow is eating the x, you're shading above. If it's pointing at it, you're shading below. If it's eating the variable, you're shading above. Okay? So what about the slope, though, when I'm doing these? Okay, so here's a couple of options you've got here. I can make myself a quick sketch in here. I'm also going to give myself a little more of a heads up here. So slope, when I'm looking at it visually, is rise over run. Which is up and down on top. And right and left on the bottom. This is more for when you're graphing. So you can decide if you want, you can make a quick sketch of a graph. If you want, I have these little graphs like this up here on my desk that you can grab and use some glue or a glue stick or something like that and kind of see. Let's try this for a minute, see how this goes. So I get that on there. Let's even say I try to do one of these. Let's do, I'm going to do this one, I'm going to do it on the review. Any 2 points, we're just counting. I went up 2, and I went right 1. Rise over run. My slope would be 2 over 1, or just 2. Either one of those is perfectly fine. But if I'm being asked to graph a line, and I'm given the equation, this is where I'm going to bust out my help sheet. I need to make sure y is by itself. So like this one is ready. If I wanted to do that one, y equals 1/3 x plus 2. The plus 2, that is my y-intercept. That is my b. That's always what I'm going to graph first. So I put that on my graph. And then my slope, my m, is 1 over 3. So if I need to, I go, okay, wait a minute. So this is up 1, and this is right 3. And then up 1 and right 3. And connect my dots. Even if you sketched a graph, which might be every bit as good, we could do that. But I always need to make sure, before I try to do this, if y is not alone, I got to do just like I do with an equation. And divide those out. Y-intercept, and you might be like, well, wait a minute, though. If I got to go down 3 and right 1, I kind of run out of room. Well, you can do a couple things. You can guesstimate, or instead of doing down 1 and right 3, you can just flip where the negative goes. And go up 3 and left 1. And that will get you on the exact same line. So again, it kind of is your call on some of these, on what you want to put and where you want to put it. But I'd make sure I definitely had that graphing. Slope, we are going to be doing some major filling of that slope box here in a minute, because I remember what's coming next. So, all right, graph it, solve for y. Graph the inequality. Oh, yeah. I'm going to do another sketch here in a minute. Or maybe, let's do this. So let's, whoops, got to be on the screen, Hardy. Let's say we're going to graph this inequality, because we see we need that too. So I got my little sketch of a graph here. Graph my y-intercept, which is at -2. 1, 2, 3, 1. 1, 2, 3, 1. Here's where I got to be careful. Solid versus dotted. It's going to be a solid line because of the line under my arrow. And when it comes to shading, if y is greater than, we shade above. If y is less than, we shade below. So like here, since the arrow is eating y, we're shading above the line. So lots of little details to be watching out for when we're doing that. And there's no way to prepare for every single situation on this. We're going to be ready for about 80% of it, which would be pretty good, actually. The one last one I would make sure gets onto my note sheet, and we got room for it here on the slope part. Write the equation of the line when you're given 2 points. I'm literally going to copy this one. This is the one extra one I want to make sure I get. So we want slope-intercept through these 2 points. So we got all the things. We're going to have 3 steps to do, so we're going to fill up most of the rest of our box with this, but it's going to be everything we need. Job 1. Find my slope. I've got my slope form right here. So y2 minus y1, x2 minus x1. So I get each of those set. I find my slope. Okay, my first job is done. Even when you're doing the final, if it's not a multiple choice, show me as much as you can, because even if you did the slope and stop, you're still getting points. Job 2. Tells you what to use. It tells you to use point slope. So here, I'm going to make myself a little note over here. I'm going to know exactly where to plug everything. And then I'm just going to start looking where the values are to plug them in. Those tell me what to get. I plug in what I got. And now my last job is to solve this equation for y, which should only take me a couple of steps here. Distribute to get rid of my parentheses. And I get to y equals. That shows you everything slope related in one question. Finding slope, doing point slope, getting into slope-intercept form. That's a pretty solid note sheet that we've got at this point. Like I said, in that extra examples, you may find a couple of things that you might want to put in there. A fraction problem, an extra graphing problem, whatever that is. But as far as this stuff goes, you've got all of that. And all the rest of this is stuff going back that we had done previously, and that's the end. So, one last thing to show as we wrap here, just a moment. Back over on Classroom, 2 things to take note of. Number 1, here is my version of the notes. So if you want to just look at mine and see what's already recommended and copy, you can. Otherwise, you can come over here. There's videos of all the individual lessons. This one will be up with it here a little later. Here's answer keys if you've been working on parts and just haven't quite gotten to all of them yet. And I still have blank note sheets in the back, but I also have them on here if you forget and want to make your own at home. So take advantage of the options that you have and the tools that you have to make this go great.